Okay, we're going to make this really quick because all the others have failed. So you need to make sure that you read through the factors that affect reaction rate and the pre-lab. We actually have gone through this in class. We set up the equation. If this one is not balanced, you will need to balance it. If you need it a little longer, make sure you pause the video. Like I said, I'm going to go fast. So on A, reacting magnesium ribbon with hydrochloric acid, you're going to be given a well plate that looks like this. You're going to be using at least 3 wells, so you'll need to tell me what you're doing in each well. I'm going to show you the reaction. The reaction is using hydrochloric acid, 3 molar, and you're going to put drops in here. I would suggest between 30 and 40 drops. I'm just going to put some drops in so you can see the reaction. You need to keep the drops total the same. So I could take 30 drops of hydrochloric acid in one. I could put 20 drops of hydrochloric acid and 10 drops of distilled water in one. I could put 10 drops of hydrochloric acid and 20 drops of distilled water in one. But when we react, we're going to get hydrochloric acid. Or not. When we react magnesium with hydrochloric acid, we're going to get hydrogen gas and magnesium chloride. Please don't breathe this because it's going to be really bad. Sometimes some of the hydrochloric acid comes up in it. But you're going to time it from the beginning you put the magnesium in until it stops reacting. This is experiment A. You are going to choose what experiment you do to test concentration, what one you do to do temperature, and what one you do to do particle size. You have to decide which one you're going to use for each, but you've got to use all 3 reactions. So this is A, and you could use this to vary concentration, and you could vary the particle size. You could cut the magnesium ribbon into 3 equal things, and then take one third of what you cut and cut it in half, and then take the other third that you cut it as small as you can, and one piece you left whole and put it in. So that's that one. That is A. And B, we're going to do down here at the bottom is reacting a seltzer tablet with water. And to do that, we're going to use a film canister, and the film canister has marks on it that you can use, 1/4, 1/2, 3/4. Some of them have a third and a 2/3. Decide what you want to add as far as water. You could change the temperature of the water by adding cold water, ice water, room temperature water, hot water. So you can change that and hold the volume constant. You could change the particle size because you're actually going to be given 2 tablets. You could cut them in half. You could cut them in 1/4. You could do a whole tablet. That would change the concentration. Or you could cut them all in half and use a mortar and pestle to help get varying degrees of crushed out of it. So what you're going to do here is you're going to fill it up, and you're going to actually do this one outside. So this one would actually work for all. You could vary the concentration, you could vary the reaction temperature, you could do a whole bunch of things. So I'm going to put a whole tablet in, turn it upside down, and back away. You're going to do 2 things on this one. Your independent variable is always going to be time on all of them, but this one's also going to have an independent variable dependent variable of height. So you can see that went off. So we're going to count how many bricks high that went. If there's any left over on tablet, I want you to make sure that you pick that up and clean it up. Okay, the third one we're going to do is over on this side, reacting sulfuric acid with sodium sulfate, and it sort of goes through it here. I'm going to do it with you right here. So you can have your petri dish. Now the ice cream lid that I just used, you can use that to put the petri dish on with warm water in or with ice water in, or you could just set it and do room temperature, so you can vary the temperature. This one you cannot vary the particle size, so you're going to need to do concentration or temperature. I'm going to put sulfuric acid on this side, and on the other side I'm going to put universal indicator. I'm going to put it on the inside. I did 2 drops, so I'm going to do 2 drops on outside, and I have to keep that consistent throughout. So I put one inside and one outside. That way I can tell when the reactions happen. Now I'm also going to put on top of the sulfuric acid some sodium sulfite, and I'm going to do that quickly and then put the lid on. Now you'll notice as we go here that the inside indicator will start changing color. As it starts changing color, you and your partner need to decide when you're going to call it. So that when it has a full yellow ring around it, when that ring turns to orange, when the whole thing turns to bright red-orange, when are you going to decide that you are going to stop this? So you're going to time it. So again, this one can be used in concentration and temperature. Now, your job is to write up the 3 labs, deciding which one you're varying for concentration, which one you're doing for particle size, and which one you're doing for temperature. It does walk through that on the second page, so you can sort of see what's going. Remember, your dependent variable is always time. For the Alka-Seltzer rocket, it is also height. And that's it. Thanks.